Hello everyone and welcome to this review. So let's get started. This review is about the redox reactions and electrolysis. Okay, so the first question asks you, in a redox reaction, reduction always involves. Actually, if you read the answers, the multiple choices that you have it here. So the best answer here, or the correct answer is gain of electrons, because reduction is gaining of electrons. Whenever a species gains electrons, this is considered to be a reduction. What is the oxidation number of nitrogen in nitric acid? So whenever you're asked about the oxidation number, so immediately use the equations just to, and the rules that you know about the oxidation number to get this number. So the hydrogen in HNO3 just one, so it's one atom of hydrogen, then one atom of nitrogen, then we have three atoms of oxygen. All the sum of all oxidation numbers in any neutral compound is zero, so in this case it's zero. Then we will put the values for the hydrogen and the oxygen. Hydrogen is always positive 1 in a compound, oxygen is always negative 2 in a compound, multiplied by 3, and n is here, so all of this equals 0. When you do this, you solve for n, so n will equal positive 5. So here is positive 5. Third question, in the reaction iron, when it reacts with copper ion, it produces iron and copper. Okay, and the question asks you here which species is oxidized. Okay, so when at the beginning, if you are asked about the which is oxidized, which is reduced, or which is the oxidizing agent, which is the reducing agent, guys, I'm telling you always you should choose one of these, one of the reactants. Don't choose from here. Okay, so one of the reactants, if one is reduced, the other is oxidized. Okay, we choose from both of these. That's the first part you should focus on. The second part, let's do the use the oxidation number rules as a reference for the oxidation and reduction happens in any chemical reaction, because it's easy to get it. Iron, because it's uncombined element, so it has an oxidation number of 0. The copper, a positive ion, it has the oxidation number here is positive 2. The iron is positive 2, and the copper here is 0 as an combined element. Okay, so you can see that the iron, the oxidation number of iron has been increased from 0 to positive 2, which means that oxidation happens to the iron, and we choose the iron as the oxidized species. Question 4, which reaction is a redox reaction? Okay, so guys, from the first site that I see this question, question B, choice B is the correct answer, as this is considered to be single displacement reaction. In any single displacement reaction, you can identify that this is a kind of redox reactions. Why? Because the zinc will displace the hydrogen, and the oxidation number of zinc is going to be changed after the reaction. Let's do it. This is the only example. If you do the oxidation numbers, zinc has an oxidation number of 0, okay, because it's uncombined element. The hydrogen in the compound has only a value of positive 1, so the chlorine will be negative 1. The zinc here is 2 positive. Actually, guys, the zinc is always 2 positive. Okay, so you just memorize this. And here the chlorine is the chlorine or chloride ion is negative 1 multiplied by 2, so it's negative 2 plus 2, so the total is 0. And the hydrogen here is 0. So it's obviously that the zinc has been oxidized by increasing the oxidation number from 0 to 2, and also the hydrogen has been reduced as the oxidation number getting reduced to 0. Okay, so this is the only redox reaction that happens here. Oxidation happens to the zinc, and reduction happens to the hydrogen. During electrolysis, reduction takes place at, that's very important, the reduction always takes place at the cathode. Okay, don't forget this. Try to remember this. As always, reduction, gaining of electrons, happens at the cathode. Okay, oxidation, losing of electrons, happens at the anode. Okay, During electrolysis of molten sodium bromide, so water doesn't exist here, as we said before. The product formed at the anode is positive, so I'm going to choose the negative ion, which is the bromide. Bromide ions at the anode will be oxidized, forming the bromine gas. This is the answer. And this because the anode is positive, so the negative ions will go to the anode, and there they are oxidized from bromide ions into bromine gas. Question 8. Which of the following is the correct half equation for oxidation of chloride ion? So oxidation means losing of electrons, and chloride ions Cl negative. Okay, so the A or C could be correct, right? Because this is the only equation that starts with chloride ions. But I'm going to choose A, because A is the correct answer, because this is the balanced equation for the oxidation of chloride ions. C is not correct because it's not balanced. In electroplating, okay, the electrolyte must contain ions of the metal being used in plating, and this is the correct answer, because this is one of the conditions in electroplating for choosing the electrolyte, that the electrolyte should have the positive ions of the metal being used in plating. Okay. Question 12. In electrolysis, electrons flow in the external circuit from, guys, you know that the electrons are always moving from the positive to the negative, right? So it goes from the anode to the cathode, from the positive to the negative, because the anode takes the electrons from the negative ions when they are oxidized, and the cathode delivers the electrons to the positive ion when they are reduced. So it goes from the anode to the cathode. Question 13. In the electrolysis of aqueous sodium chloride, so this is aqueous, so water exists, one product at the cathode, so the cathode is actually negative, right? And the sodium is positive, so sodium exists. And also don't forget that the hydrogen of water ion, hydrogen ion of water exists as well. How did I know? Because this is aqueous solution, okay? So hydrogen exists. So when you compare hydrogen to sodium, to which one is going to be reduced at the cathode, so I'm going to choose the hydrogen gas will be reduced at the cathode, because hydrogen is less reactive than sodium. Question 14. Which statement is true for the electrolysis of molten lead bromide? Molten, so lead and bromide, they exist. This is positive, this is negative. Okay, so lead produced at the anode, this is incorrect, because lead is positive, anode is positive, so it's incorrect. Lead is produced at the cathode, yes, this is correct, because lead is has positive ion because it's a metal, and the cathode is negative, so this is a correct answer. Question 15. The reaction Mg, magnesium, reacts with the hydrochloric acid to form magnesium chloride and hydrogen gas, involves what? A. Oxidation of magnesium and reduction of hydrogen ions. Actually, when you revise the equation, this is actually a correct answer. Oxidation happens to magnesium. Why? Because magnesium has oxidation of 0 before the reaction, and after the reaction it has an oxidation number of positive 2. How do I know that it has positive 2? Because magnesium belongs to the group 2 in the periodic table, so it has an oxidation number of positive 2. So it actually increases from 0 to positive 2. So this is considered to be oxidation. Oxidation of magnesium happens. So let's talk about the reduction of hydrogen. The hydrogen in the hydrochloric acid actually has oxidation number of positive 1. Okay, and after the reaction it has an oxidation number of 0. So when it goes from positive 1 to 0, so it means it decreases, so reduction happens to the hydrogen. So this statement is actually correct. In the reaction of iron with the manganate, okay, it produces iron, and the iron ion and manganate, it produces the iron 3 ion plus the manganate 2 positive ion. Which species is the oxidizing agent? Whenever a question asks you about the oxidizing agent, you should go and search for the one who is reduced, okay, because the oxidizing agent is actually reduced in the reaction. Okay, so Fe has positive 2, as oxidation number is positive 2, it equals to the charge of the ion, and here it equals positive 3, so it goes from positive 2 to positive 3, so iron is oxidized, so this is not the answer. While manganate, the Mn in manganate, if you calculate the oxidation number of manganate here, it will equal positive 7. So it goes from positive 7 to positive 2. So in this case, manganate has been reduced. So manganate is the oxidizing agent. Okay, this is the correct answer. So manganate is reduced, it is the oxidizing agent. Which is the correct description of oxidation? Which is the correct description of oxidation? Oxidation, loss of electrons and gain of oxygen. Actually, this is correct. Okay, one of the definitions that the oxidation happens by losing of electrons and also by adding oxygen or gaining of oxygen. Electroplating is used to, so I need to know, we said that before, electroplating, a process happens in industry just to prevent corrosion and improve appearance. Okay, prevent corrosion, like to prevent like rusting, and also to improve appearance, like have the metal will have like better and shiny appearance. Okay, in the reaction 2Na plus chlorine gas, the sodium chloride is formed. Sodium is, so we need to know what happened to the sodium. The sodium at the beginning has oxidation number of 0 because it is uncombined element, while sodium in sodium chloride has an oxidation number of positive 1. Why? Because in the rules, sodium belongs to the first group in the periodic table, so it has an oxidation number of positive 1. So sodium has been oxidized because the oxidation number has been increased from 0 to positive 1. Which ion is reduced during the electrolysis of aqueous silver nitrate? So it is aqueous silver nitrate solution. Okay, aqueous silver nitrate solution. So it has silver and hydrogen gas at the cathode, right? So it asks you here which is reduced. Okay, reduced means the reduction, and we know that reduction happens at the cathode, right? You know that reduction happens at the cathode, right? So which ions are going to move to the anode? The silver ion, Ag, positive 1, and guys, the Ag, the silver, is always have an oxidation number of positive 1, always. Okay, and the hydrogen ion also exists, H positive, but in this case we said silver is going to be reduced because silver is less reactive than hydrogen. So in this case, silver will be reduced at the cathode, producing silver ions. Which of the following is not a characteristic of electrolysis? Okay, if you read the choices, you're going to find that oxidation happens at the cathode. This is actually incorrect. That's not characteristic of electrolysis. That's what we are searching for in this question. What happens at the cathode during electrolysis? During electrolysis, reduction happens, but guys, you should be aware that reduction happens to cations. So what is meant by cations? Cations are the positive ions, okay? Because at the cathode, positive ions are attracted to the cathode and they are reduced there, and the positive ion, in other words, is called cation. Which substance act as the oxidizing agent? So I'm going also to go to the reduced one, right? The reduced one, right? So let's use the rules to get the oxidation numbers. The hydrogen here uncombined has an oxidation number of 0. Oxygen uncombined has oxidation number 0. This is before the reaction. But after the reaction, hydrogen in any compound, almost in this compound, will have an oxidation number of positive 1 and the oxygen negative 2. Okay, from the rules. So hydrogen has been oxidized. It is oxidized. Why? Because the oxidation number increases from 0 to positive 1, while oxygen is reduced as the oxidation number goes from 0 to negative 2. So it is reduced. So the oxidizing agent, the reduced one, is the oxygen, and the oxygen is the oxidizing agent because it is the one that reduced when it goes from 0 to -2. And the electrolysis of molten calcium chloride, okay, molten, so no water here. Okay, the product at the cathode, so I'm searching about the positive ion. This positive, this negative, and the cathode is negative. Okay, so the positive ion will go to the cathode, so calcium metal forms after reduction at the cathode of the calcium ions. What is the oxidation number of sulfur in sulfur dioxide? So I'm going to use the rules and make an equation here. S plus 2 oxygen equals 0. So we know that previously oxygen has always a value of -2. So S plus -4 equals 0. So S equals +4. +4 is the correct answer. Which of the following correctly describes a redox reaction? Okay, exchange of ions between two compounds or transfer of electrons from one species. Yeah, that is the answer. Okay, transfer of electrons from one species to another, because when a species loses electrons, oxidation happens, and when the other species gains electrons, so the reduction happens. What gas is produced at the anode during electrolysis of water? So this is just only water. Water has, we know, when electricity pass through water, so it is going to dissociate into hydrogen ion and hydroxide ion, right? So at the anode, the positive one, so the hydroxide ion is going to be attracted to the anode, producing oxygen gas. Okay, producing oxygen gas. At the anode, the hydroxide ion is oxidized according to this equation that I told you to memorize, producing 2 molecules of water, 1 molecule of oxygen, and 4 electrons. Which of the following substances is used as the electrolyte in electrolysis of aqueous sodium chloride? So for as electrolyte in electrolysis of aqueous sodium chloride, aqueous sodium chloride actually means sodium chloride solution. Okay, this is the electrolyte. Which of these is not a product of electrolysis of water? Carbon dioxide is not a product, right? Because water is a product, oxygen is a product, and also hydrogen is a product at the cathode, okay? So carbon dioxide is not a product as the electrolysis of water happens. What happens to the mass of the anode during electroplating silver? So when electroplating of silver, the anode will always, the mass of the anode will always decreases, right? Because the atoms of the anode is reduced, okay, when it changes from atoms to ions. Sorry, it is oxidized. When it goes to the solution, it turns from atoms to ions by losing of electron. This is oxidation. Okay, so by time the mass of the anode decreases, okay, while the mass of the cathode increases as the ions deposited there and they change into into atoms by reduction. Okay, so in this case, in electroplating, always guys remember that the mass of the anode decreases, the mass of the cathode increases. Which ion is discharged at the cathode during electrolysis of aqueous copper sulfate? Okay, so in the electrolysis of aqueous copper sulfate, which ion is discharged at the cathode? Discharge means reduced, or a change happens to it at the cathode. So the cathode is negative. So, and you know that this is the compound that we have. So copper has positive ion, sulfate has negative ion. So the copper will go to the cathode because it's a positive ion, but not only the copper is going to go there, but also the hydrogen ion of water, because this is aqueous solution. So when hydrogen ion exists and copper ion exists, both copper ion will be reduced. Why? Because copper ion, or the copper, has less reactivity than hydrogen, so it's going to be easily reduced at the cathode, changing into copper atoms. Which statement is true about oxidation numbers? The sum of oxidation numbers in a polyatomic ion equals 0. This is incorrect. It equals the charge of the polyatomic ion. Oxygen usually has an oxidation number of -2, except in peroxide. Actually, this is correct. Okay, peroxide, guys, like the hydrogen peroxide, in this case, the oxygen has an oxidation. This is kind of exception. Okay, we said oxygen always have an oxidation number of -2, but in some cases, in some exceptions, like the peroxide here, it has an oxidation number of -1. Okay? Which of the following describes the role of the electrons in a redox reaction? Electrons are lost, electrons are gained. Electrons are lost in reduction, this is incorrect. Electrons are gained in oxidation, this is incorrect. Electrons are transferred from the oxidizing agent to the reducing agent, this is incorrect, while electrons are transferred from reducing agent to the oxidizing agent. Why? Because the oxidizing agent, guys, reducing agent is the agent that is oxidized, right? And the one that oxidized, it loses electrons, right? Okay, while the oxidizing agent is reduced, right? So it gains electrons, right? So the electrons flow is going from the oxidized one to the reduced one, which means from the reducing agent to the oxidizing agent. This is all about the multiple choice questions, and now let's go a little bit for the short answer questions. So I'm going to go through the questions of short answers like quickly. Okay, I'm going to explain some of it, and some other definitions you can find it in the notes, so it's okay, you can get it and write it down when you study. Okay, define oxidation. Oxidation in terms of electron transfer, oxidation is the loss of electrons. Oxidation is the loss of electrons. Write this down, pause and write this down. Oxidation is the loss of electrons. Reduction is the gain of electrons. The second question, calculate the oxidation number of chromium in K2Cr2O7. I can work this out here, okay, as an equation, okay? So K2 means 2K atoms plus 2 chromium atoms plus 7 oxygen atom. All of this equals 0. Why? Because the total number of oxidation numbers equals 0 in a neutral compound. This is a neutral compound. It doesn't have a charge, okay? The potassium belongs to the first group in the periodic table, so it has an oxidation number of +1, and we said oxygen always have an oxidation number of -2. So 2 multiply +1 plus 2 plus 2 chromium plus 7 multiplies -2, it means -14 equals 0. When you move -14 to the other part, it's going to be other side is going to be 14. The 2 to the other side is going to be -2. 14 minus -2, it means that 2Cr equals 12. If you divide the equation by 2, the whole equation divided by 2, so the Cr equals +6. Okay, so you should, in this kind of questions, you should work it out in this way, make an equation, substitute the values from the rules that you know, and then solve for the unknown, solve for the chromium in this case. In the reaction, 2Al plus 3 copper ions gives 2Al and a copper atom. Identify the species oxidized and reduced. Okay, so we need the oxidized, and again, I'm telling you, whenever in any question you are asked about the oxidized or reduced, we always choose from both of these. Okay, so if the first one is oxidized, the second one is reduced immediately. Okay, so if you use the rules, as we said before, aluminium is just an combined element, has an oxidation number of 0 before the reaction. After the reaction, it turns into an ion of 3 positive. It means the oxidation number is +3, because this is one of the rules. The rule, the ions always have the oxidation number of any ion equals the charge of monoatomic ion, and this one is +2 and this one is 0. So when aluminium goes from 0 to +3, the oxidation number increases. So this is actually oxidation. This is the one that is oxidized. The copper ions, when it changes into the oxidation number of copper ions, +2 changes into 0 after the reaction. This is considered to be reduction. Okay, so the oxidized species is the Al, the reduced species is the Cu2 positive. Okay, half equations given the reaction. This reaction, right? They have equation for the reduction of permanganate ions. This is the permanganate ion. Okay, and guys, whenever the ion that is written in the question has oxygen with it, you should write the hydrogen with it, and on the other side write the same ion and the water. Okay, we as when the question asks you to write the half equations, half equation for both reduction and oxidation, you should divide the equation into two parts. You choose that. Okay, this example is a little bit challenging. Okay, but this is my advice when you get this, and these are the rules already, that because Mn, the manganate, has oxygen in it, so write down the hydrogen with it, so you can write the water at the other side. Okay, so I will divide it in this way. So the four of these I will write it in one equation, and the iron and iron in this side and the iron of the other side, I will write it in the next equation. Okay, so reduction of permanganate. So it is already given that reduction of permanganate. So MnO4, okay, MnO4 negative, this is called permanganate ion, plus 8 hydrogens. Reduction means gaining of electrons, right? So I'm going to add plus electrons, giving. So this is I'm doing A. Yeah? This is A. Okay. So at the other side, I'm going to write. So guys, you can see that I just wrote this. I wrote the hydrogen, okay, on the left side, okay, plus electrons. Why did I write plus electrons here? Because this is reduction, gaining of electrons. That's why electrons at the left. Okay. So let's see what I'm going to do next. On the other side, I'm going to write the Mn2 positive plus 4H2O. Okay. Easy. I just wrote the both of those here at the left, and the Mn and water here. I'm dividing the equation into two halves. Okay, and why did I choose to get the water here and the hydrogen here plus the oxygen? Because oxygen is in the same compound of manganate, of permanganate. Okay, but the hard part here is to get the number of electrons. The number of electrons. How many electrons? When you do the oxidation number of manganese in manganate, the Mn in MnO4, you will get it. It is positive 7. Positive 7. This is the oxidation number of manganese is positive 7 here. Why is positive 7? Because when you do, let's do it here at the top. If I want to get the manganese oxidation number, O4 negative. So the Mn, I will use the rules. For oxygen, the total equals -1, because we said the sum of all atoms in a polyatomic ion equals the charge. So the charge here is -1. Okay. Next, Mn plus. The oxygen has an oxidation number of -2. So 4 multiplies -2 is -8, equals -1. So when you move -8 to the other side, it's going to be 8 minus 1. So the Mn, as I said, it's going to be having an oxidation number of positive 7. Why I'm doing this? To calculate the number of electrons gained. Now, so this is the oxidation number of manganese here, and this is the oxidation number of manganese here, positive 2. So guys, what do you think? What do you think? If manganate here is reduced and it has oxidation number of positive 2, then after the reaction it turns into positive 2. So how many electrons the manganate ion has gained? How many? Yes, correct. 5 electrons. 5 electrons. Okay, 5 electrons. There's a difference between the oxidation numbers of manganese ion before the reaction and after the reaction. Okay, guys, I know this a little bit needs more steps, but finally we can get it. Okay, so this is positive 7 and this is positive 2. Okay, B. The half equation for oxidation of iron is very easy, so we'll write down the rest, right? I will write down this and the other electrons. So oxidation means losing of electrons. So 5Fe2 positive when it is oxidized. So the oxidation, after the oxidation, we write the arrow immediately. So at the other side, 5 Fe 3 positive plus 5 electrons. How do I know it's 5? Because when the iron has 2 positive charge, it means it already has lost two electrons. When it turns from positive 2 to positive 3, it means that each iron atom loses one electron. Right? So 1 electron lost here multiplied by 5, so the total is 5 electrons to be lost at the other side. This is the second half equation. Explain how electrons are balanced in these reactions. Yeah, it is balanced, 5 and 5. Yeah, 5 and 5, it's balanced. Okay, how it is balanced? Because we have 5 electrons here and we have the same number of electrons here, so we are correct. Electrolysis. Define electrolysis. We said before, electrolysis is the breaking down of ionic compound into ions using electricity. Describe the products formed at each electrode during electrolysis of molten potassium iodide. We said that before. The potassium is positive, so it will be produced at the cathode. Okay, the potassium metal, and the iodine will go to the anode, forming iodine or iodine molecule. Okay. Why must the electrolyte be molten or dissolved in water for electrolysis? We said it before. Molten or dissolved. Why? To have free ions, right? Okay. So if it is molten, the ions are free to move. You can write it in a different way, because in these two cases, in the molten state or the molten form or dissolved in water, in both cases, the ions are free to move in the electrolyte, conducting the electricity. Electroplating. Nickel is used to electroplate iron objects. Okay, identify the materials used for the anode. So in any electroplating, if we electroplate nickel to the iron, so anode is going to be the nickel itself, pure nickel. Okay, the cathode is going to be the iron, the one that will be electroplated. The electrolyte, it has to have nickel ion. Okay, that's it. Refining methods. Copper is purified by electrolysis. Explain what happens to the impure copper anode and the pure copper cathode. Okay, the impure copper anode the mass is going to decrease, right? Its mass decreases by time. Okay, while the pure copper, the mass will increases by time of all of them is going to be pure copper. Okay, the impure copper, the copper atoms at the anode is going to change into copper ions. This is oxidation. Okay, while at the cathode, the copper ions will move to the cathode, attracted to the cathode. So the copper ions will gain 2 electrons to form copper atoms. That's why the mass increases at the anode, at the cathode. Half equation practice. Write the balanced half equation for the redox processes. Reduction of silver to ions to silver atom. Ag. Reduction means gaining of electrons. Gains 1 electron, changes into silver atom. The iron, oxidation of iron 2 to iron 3. So Fe2 positive gives Fe3 positive plus 1 electron, because this is losing of 1 electron. The third one, copper 2 plus the reduction gaining of 2 electrons, it turns into copper atom. Okay. Oxidation number practice. Assign oxidation numbers to all atoms in this compound. Okay, let's work this out. This is the last question. H2, so 2H plus S plus 3 oxygen equals 0. It means that, and we know that the hydrogen has a positive 1 value, the oxygen negative 2. So here it's positive 2 plus S plus negative 6 equals 0. Move 6 to the other side is going to be 6. positive 2 is going to be negative 2, so the S is going to be positive 4. Okay, in this case, guys, you should write that the hydrogen equals 1, oxygen equals negative 2, S equals positive 4. This is the final answer for A after doing this. Okay, you should write this is the final answer, because the question asks you assign the oxidation numbers for all atoms. So this is A. B, NaNO3. Okay, so Na plus N, Na the sodium, plus N nitrogen, plus 3 oxygen equals 0. Na belongs to the first group in the periodic table, so it has an oxidation number of positive 1, plus N, and we know that oxygen equals negative 2, negative 2 multiplies 3, negative 6, this is equal 0. When you move negative 6 to the other side, it's going to be 6. Positive 1 to the other side, negative 1. So the N has an oxidation number of positive 5. So in this case, I'm going to write down that Na has an oxidation number of positive 1 because it belongs to the first group. N, we calculated positive 5, and oxygen originally has an oxidation number of negative 2. This is the answer. Okay. C, the KMNO4, potassium manganate. So in this case, K plus Mn, the manganese, plus 4 oxygen equals 0. K belongs to the first group, like the sodium. It is under the sodium in the periodic table, so it has an oxidation number of positive 1. The manganese is unknown. 4 oxygen means negative 8, because the oxygen has an oxidation number of negative 2. So this is equals 0. So when you move negative 8 to the other side, it's going to be positive 8. And when you move positive 1 to the other side, it's going to be negative 1. So 8 minus 1, so the manganese will equal positive 7. Manganese equals positive 7. And in this case, the K has an oxidation number of positive 1. Mn has oxidation number of positive 7. And the oxygen has oxidation number of negative 2. This is the final answer. Okay, guys, I wish you all luck. Okay, study hard. Repeat this video again and again. Go with each word in it. Inshallah, the exam inshallah is going to be easy if you understand all the concepts and all the ideas that in this video. Okay, best of luck. Bye bye.